This is really math 8. This should be review. This is, you're just taking the first step off of the edge of the pool onto the very first step. So right now the water comes up to your ankles barely and it's nice and warm. Ooh, comfy. Pythagoras. Those of you that have not had me before, I'm a little different in terms of showing work. I would say to you, for things like Pythagoras, if when we get to the homework, Johnny, you can get the correct answer straight on your calculator, not writing anything down, and write the answer, not showing any work, I'm fine with that. I will assume you didn't cheat and get the answer off of a neighbor. On a test, I would say always show one line, just in case you make a dumb mistake. My stupid joke, I never make mistakes, is that, you know. And what I mean by those is, a mistake is when you go 2 times 3 is 5. I added it instead of multiplying, because 2 and 3 are associated both with 5 and with 6 in my head. Those kind of things. Always write down at least one line of work on a test for every step that you're doing. But in your homework, I kind of like it if you can do stuff in your head. I think that's becoming an expert, as far as I'm concerned. In our notes today, we'll try and do this with only one line. Trigonometry is the study of triangles. Triangles have been used for years in engineering and architecture because it's very easy when you're looking at a physical situation to draw a triangle in there and you can now interpolate some information. Pythagoras was a famous Greek mathematician who lived in the 6th century. He and his followers, the Pythagoreans, studied many properties of numbers. The most famous discovery made by Pythagoras was the relationship between the side lengths of right-angled triangles. That's a lie. I need to correct that. He didn't discover it. It's named after him. In fact, we think it's been discovered independently 3 or 4 times. I believe China discovered it as well, and I think the Egyptians had it as well. What is Pythagoras? First, we need to name the sides of a right-angled triangle. The side across from the 90-degree angle, that one there, is called the hypotenuse. And in Pythagoras, we typically label it with the letter C. In trig, we typically label it with H for hypotenuse, and so we'll flip-flop between both. The other 2 sides are called legs. The legs of a triangle, and often we use A and B. We're going to get more specific in the next lesson. You can put A there and B there, or you can put B on the vertical and A on the horizontal. Lachlan, doesn't matter. What is important is you have to get the hippopotamus, the hypotenuse, that thing. You have to get that thing right. And that's by far the most common mistake, is kids get sloppy with the hypotenuse. And Pythagoras says this, a squared plus b squared equals c squared. The length of one side squared plus the length of another side squared is the hypotenuse squared. And there are, at least hundreds of proofs, maybe more of that. Sometime I'll show you a few. You can use this to find a missing hypotenuse or a missing leg. Those of you that have not had me before, you should know that I tend to abbreviate. See how I did that? Yeah, nothing. Okay. So let's look at example 1. It says find the missing side. If you were in grade 8, I would have you all write down a squared plus b squared equals c squared. I would have you label the triangle with an A and a B and a C. Don't do that. I would have you write out all the numbers. You know what? We're in grade 12. In your homework, if you can do this straight on your calculator without writing anything, I'm good with that. We want to write down one line in our notes, just so that when we're studying, we can remember what the heck we did. What could I write? One line. Give it to me. Maddie. What squared plus what squared equals what squared? Yep. No, there's an X there. Sure. If you put a C, I'm not taking marks off, but let's use their variables. I did a quick check, Maddie. I noticed everything was centimeters. I didn't have to do any unit conversions. And if I notice that all my units are good, I don't bother including them in my equations because it just clutters things up. I would now go straight to my calculator. Now, I really teach how to use a calculator and use it well. What am I going to do? I'm going to add those together, and then how will I get the x by itself? What will the final thing be that I'm going to do be? What mathematical operation will I perform? Square root. When I'm square rooting something big, some of the newer calculators, especially the newer Casios, when you hit the square root button, it does like a little indentation and it's all inside the square root. Most of yours don't. And so typically what I do, Nina, is I type what's inside the square root. 56 squared. And then what I do is I go square root answer button. My answer button on a TI, it's usually shift and then next to the equal sign. Many of you have an ANS button right beside your equal sign. Some of you, your answer button will be shift and then the equal sign. So those of you that were in Physics 11 last year, for example, when we did relativity with all those square roots inside Einstein's equations, I always typed what was inside the square root first, hit equals, and then went square root answer button. It was less writing and less room for error, and you didn't have to track all these brackets around or keep track of things. Brackets on calculators are fairly confusing. Not always, but fairly. 65, yes? No, yes?
Yeah.
And I'm fussy, always put units on your final answer. I have a habit, typically once I've found a final answer, I put a box around it. That is my spiking the football after a touchdown routine. You don't have to. It's just a habit I developed over the years. Also because later on this year, when we're doing questions that are pretty long, and you will be doing, when we do rocket science, a question that takes up an entire page, you will want to spike the football. Trust me, when you get there. It's pretty good. Example 2. A rectangular lot has dimensions of 16 by 28 meters. Find the length of the path that runs diagonally across the lot. James, I have an acronym that I give kids. In fact, I have two main strategies when it comes to solving physics questions. One is called DFIC, which stands for Data, Formula, Insert, Crunch, and I'll show you that another time. But one of my other acronyms or strategies is DOLP. What does DOLP stand for? Those of you that had me before. Draw a little picture. When in doubt, DFIC and DOLP. When in doubt, draw a little picture. So, I'm going to draw a rectangle. Ooh! Oh, look at that! I'm going to draw a rectangle. You can freehand. I'm going to put the 16 right there and the 28 right there. Now, I noticed the 28 was bigger, so I put it on the longer side. Honestly, the math will still work if you put the 28 on the shorter side, because the rectangle is just to give you a guideline. And then I think the diagonal is that right there. And my variable of choice for generic math problems is an x. In physics, I will almost always use the variable that matches the particular approach or equation or concept we're trying to find. I want to write one line, no more. What can I write, Jacqueline? What squared plus what squared equals what squared? Sure. Will this one work out evenly? I'm not so sure. Don't think so. Well, maybe. Nah, I'm not feeling it. No. Mr. Dueck? What, Jacqueline? How many decimals do you want us to go to? You know what? In Physics 12, I'm very pragmatic. Go to 3 sig figs. 32.2. Go to 2 sig figs. I'll take 2 or 3 sig figs, but you don't need to go more than that. So 32.2 is fine. You don't need to go 32.24903.099. You don't need to go 32.25, even though there's a 9 there and you might be tempted. That's a nice place to round off. 3 sig figs is good. 32.2, and that's meters. Sometimes you're finding a missing leg. I'd like to write one line. Colby, what can I write?
X plus 55 squared.
Oh, he made a mistake. Did you hear what he said? He said x plus 55 squared. I don't think he meant to say x.
Oh, X squared.
What?
X squared.
Yeah, and you know what? I would have no problem if you wrote x squared plus 55 squared equals 73 squared, except I'm lazy. I wouldn't even go there. Can you give me the line that I would actually use to solve this?
X equals 55.
Oh, he's thinking now. I can hear the hamster running on the little wheel up there. Squeak, 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 squeak. Lachlan, what was it? It's not 73.
70 squared.
Ah, thank you. I would go, okay, 73 squared minus 55 squared, that equals x squared. And that's what I would go straight to my calculator on if I could. Yes? Is that what you were trying to get out? Yeah, we could all tell. I think this one works out evenly. I would also say to you there's a built-in error check. If this diagram is roughly to scale, x has to be smaller than 55. If I get an answer bigger than 55 because I accidentally hit plus instead of minus because I'm just not thinking very carefully, I hope you would catch that. One of the things I'm going to try and teach you, Johnny, is always have an idea of whereabouts the answer should be and don't trust your calculator. Whenever I teach you a new concept, I will give you an idea of this is what's really big, this is what's really small, and so hopefully if you've made a really, really spectacular error, you'll be able to look at your calculator and say, yeah, I don't think that can be right. I love that. What'd you get? Sorry? 48? Works out evenly? Nice. This is, by the way, way back when I used to teach Math 10 and Trig was in Math 10. This is a lesson I created about 10 years ago. And apparently at that time, I cared enough to make things work out evenly. I don't anymore, and that won't happen very often. Example 4, what's the first thing I'm going to do for example 4? Maddie, what? Oh, absolutely. A ladder, I'm going to freehand this, is leaned against the wall. There's the ladder. There's the wall. I see a triangle. Where is that 5.3 going to go? The vertical side, the horizontal side, or the slanty side? Michael. Okay. Could have said that right away and saved us 30 seconds of awkward silence. Where's that 1.2 going to go, Michael?
Bottom side.
And then I guess I can go. So, pause for a second. It appears that if I have a right angle, if you give me two sides, I can find the third. No situation that won't work for. What we're going to ask on Monday is, if I have a right angle, what if you only give me one side and an angle in the triangle? And that's what we're going to be using like crazy. Like crazy. In fact, that's what hopefully you're also going to get good enough at that it becomes as boring as Pythagoras. As going straight to your calculator, almost. Or writing one. Typically with trig, I write down one line and then I'm good to go. What's my equation, Michael? That's how to do it, Colby. I'd be stunned if this works out evenly, although it might. So I go 5.3 squared minus 1.2 squared, square root, answer button. Yeah, 5.16, 3 sig figs works for me. 5.16, and what were the units? Probably meters. Yeah. Also, again, a built-in error check. I knew the answer had to be less than 5.3 because the hypotenuse is always the longest side. I knew the answer, looking at my roughly drawn to scale picture, was probably significantly larger than 1.2. Ballpark, that seems right to me as well. Some questions require more than one step. A ramp is placed on two cement blocks that are 1.2 meters apart. The blocks are 2.3 and 4.1 meters high, respectively. Respectively means in that order. Find the length of the ramp. Maddie, what am I going to do? Darn right. Two cement blocks. So I think here is one cement block, and the other cement block, it says, is higher. And now that I've drawn that, I think I see what they're getting at. I think the ramp is that. Can you see the triangle? In fact, I might even be tempted to go just so that my brain, which is tired first thing in the morning, says, hello. What are they asking me to find? So where am I going to put the x? On the slanty side, on the horizontal side, or on the vertical side? Here? I think I disagree. I think the length of the ramp, I think it's that. Let's convince ourselves. Where's that 1.2 going to go, Lachlan? Where's that 1.2 going to go? That's going to go on the horizontal, yes? Now I need this. How? Oh. So you're telling me if that's 2.3 and if that's 4.1, this little section right here is 1.8? I did the math in my head. Double check me, yes? Oh. And now I've turned it into Math 8 again. You know what? Show no work. Can you go straight to your calculator? You get 2.163, 2.16?
Yeah.
One more. A handy way to label triangles is to put letters on every corner. The fancy word for a corner is a vertex. Put letters on every vertex, and then to talk about a specific side, I give you the two letters on either end of it. So it wants me to find AB. It wants me to find that. They could have given me this in English, but they did give me a picture, Maddie. I don't need to dulp, but I think I'm going to label stuff. 26. I think there, yes? Where's that 31.5 going to go? Now, I'm a little worried, Aisha, don't write this down. If I just did this, I don't know whether that 31.5 belongs on that short chunk, that not quite so short chunk, or the whole chunk. And I also have a sneaking suspicion I'm going to want to write more stuff. So having done these before, I'm going to drop down a little bit, leave some space. I'm going to put the 31.5 there and indicate that that's how it goes. And then AC equals 10. Okay. How can I find AB? Your hint is this will take more than one step. Find CD first. Oh, are you saying that this right here is a lovely right angle triangle and I can use Pythagoras? Okay. I'm lazy but organized. You said find CD first. I'm not going to write that out, but I want to make a note that's what I did. I have an idea. How about I go CD colon? I think when I look back later, finding CD. Can you give me the equation? What squared plus what squared equals, or what squared minus what squared equals what? And you know what? Now I'll put an X there. This might work out evenly. 10 squared is 100, 26 squared, 25 squared is 625, 26 squared is 600. I've forgotten my squareds. It does work out evenly, doesn't it? $24? Yeah. So now I'll add that to my diagram. I'll put it right above the X, I think. How's that help? Okay, how's that help?
Good.
Yeah, no, how does that help?
Oh, to the equation?
Now what?
31.5 minus 1.
Oh, I can get BC?
Yeah.
So I'm going to change colors. This is why having multicolors is sometimes helpful. You don't have to, but I will. I'll go red. How long is BC? 5.5? 31.5 minus 20, 7.5. I looked at the 26. That was a dumb mistake. And so now, I'll put a y there. There's another variable I can go with. To find AB, I guess it's going to be 7.5 squared plus 10 squared equals y squared. I doubt this will work out evenly. You know what? It actually might work out to a nice decimal. I think so. Oh, there you go. Yeah, 12.5? Units, millimeters. There's a very quick review of Pythagoras. What's the Pythagoras equation? It's a squared plus b squared equals c squared. It's an easy one to remember because it's alphabetical. Do you need to memorize it? It's actually on your yellow sheet. I think on the back page, there's some triangle stuff. There's the quadratic formula. There's sine and cosine and tangent, which you'll learn about on next week. So technically you don't, although if you're looking up Pythagoras, usually my eyebrows go, that's one that most kids have committed to memory just because it's almost poetic. A squared plus b squared equals c squared. It's alphabetical with the squares. What's your homework? You can do number 1, all of it. Now, if Victor, you can do number 1 without writing anything down and just writing down the answer, and you write down the answer going straight to your calculator, I will assume that that's how you did it, and I'll take your word for it, because I did attach the answers at the very, very back on the last page. I'll assume you weren't just, I'm going to copy the answers. I'd like you to get to the point where Pythagoras is pretty much the same as going 5 times 6. Not much more difficult. It's just that you need a calculator for some of the more complicated ones. So number 1. Yeah, 2 is good. Yeah, 2 all. Ooh, F. You'll have to do a little thinking. 3. I like A. I like B. Now I'll skip C and D. No, you know what? D I'll do. I'll skip C though. No, never mind. I'm going to skip D. Haha, fooled you. Let's go E. I like that. Let's go F. I like that. We'll skip 4 and 5. You should get it done in class, I suspect, because you've got 20 minutes. When you finish homework in my class, let me pause the video.